Hi guys, welcome to iCode to Learn. This is part 5 of Azure tutorial. As part of this video we will cover the following topic. The first one is, what are deployment slot and slot setting, and when to use them? What is zero-time deployment, and how to achieve it with deployment slot? How to test the production code before deploying to production with real-time users. We'll try to understand all these with demo.
Before getting started with deployment slots, it is good to know about Azure App Service and App Service Plan. I will give quick introduction to App Service Plan and App Services so that you can easily understand the deployment slots. One App Service Plan can contain multiple app services as shown here. Operating system and computer resources are defined at App Service Plan level, and all the app services shares the App Service Plan resources. One app service can contain multiple slots. By default, an app service itself is a slot that is nothing but default slot. The name of default slot is production, and each slot acts like a standalone application. While creating slots, we can give any name to custom slot, as here I have given UAT in stage. In standard app service plan, it allows to create maximum of 5 slots, including default slot for an app service.
As part of this demo, we are going to create a resource group. If you are not familiar with the resource group, please do watch part 3 of Azure tutorial where I explained about resource group and its importance. As part of second step, we will create an app service plan. Here we need to choose pricing tier either standard or above, because deployment slots are only available in standard or above pricing tier. As part of third step, we will create a deployment slot, and then we'll create .NET Core project and deploy it to app service and deployment slot. And then we'll configure the app settings and slot setting in Azure and observe the result. With this information, let's get started with the demo.
Open browser and navigate to portal.azure.com. As part of first step, create the resource group. A resource group is mandatory to create any service in Azure, and it is free of cost. To create a resource group, click on Resource Groups from Favorites menu and click on Add. Leave the subscription to its default. We'll discuss this in later point of time. Give any name in resource group. I am giving here it has slot testing. Leave the region to its default, and then click on Review and Create. You can see the newly created resource group under Resource Group section. As part of next step, create an app service plan. Click on Add button from the resource group and search for App Service Plan. Select the App Service Plan from the result. Click on Create. As we are creating this app service plan from slot testing resource group, the resource group drop down here is defaults to slot testing. We can also change the resource group from here, so that this app service plan will be created in that particular resource group. For now, keep the subscription and resource group to its default. Give the app service plan name. You can give any name. I am giving iCode to Learn. Select the operating system as Windows. Keep the region to its default. We'll discuss about the regions, like which region to select and other information in our upcoming sessions. And the most important part here is pricing tier. You will be charged based on the pricing tier that you select. Here I am selecting standard S1 pricing tier because deployment slots are only available in standard or above pricing tier. We can change the pricing tier by clicking on Change Size. Here we can see all the available pricing tiers. For now, select S1 and click on Apply. Click on Review and Create. Click on Create. Deployment is in progress. Service creation is in progress. Once it is completed, we can see Go to Resource button, click on it to see the created app service plan. Now our second step is to create app service. Search for app service from the search bar. Click on App Services from the available list, and then click on Add. Here select the resource group as slot testing, and give app service name. App service should be unique globally, because the web application URL will be generated based on the app service name. For example, if we provide ABC as app service name, then the URL of that particular app service is abc.azurewebsites.net. Select the publish type as code, because here we are going to deploy the code, not the Docker container. Select the runtime stack as .NET Core. We can also select other types like Node and Java. For now, select the .NET Core. Select the operating system as Windows and location as Central US, because we created our app service plan in Central US. Click on Review and Create. Click on Create. Deployment process is started. Once after completion, we can see Go to Resource button. Till now, we have created a resource group, app service plan, and an app service. Now we need to create a slot in app service. Click on the app service. Go to Deployment Slots options from the app service menu. If you observe here, a production slot is created along with the app service. With this we can say icode to learn app service is pointing to production slot. If you are not clear on this statement, do not worry, you can understand it clearly in a bit. To create new custom slot, click on Add Slot. Give the slot name. I am giving it as stage, but you can give any name. This is URL to access this slot. If you observe stage slot URL, it is just adding hyphen slot name to the production slot URL. The takeaway from this point is, custom slot URL contains production slot name hyphen custom slot name. Clone app settings option is to clone the existing app settings from the production slot. Click on Add to create new slot. Slot created successfully, click on Close, new slot added to the deployment slots. Both slots running under same app service plan. The traffic section here is used to divide the requests between the slots. For example, if we give as 50 and 50, then when we access production slot URL, half of the requests will go to production slot and remaining will go to stage slot. This option is useful to test the application in production. We'll see this in a bit. As part of next step, we need to create a .NET Core web application and deploy it to both slots. Open the Visual Studio and create a .NET Core web application. To make it fast, I have already created a .NET Core web application. It has a home controller and index action method. If you observe, I am reading app settings using iConfiguration and returning them to view. I have added two app settings. First app setting key is slot testing and second app setting key is non-slot testing. For both the keys I have given value as local. Try running this application in local and observe the result. Now deploy this application into both the slots and configure the app settings in Azure. Navigate back to Azure. To understand it better, I am opening production slot in one tab and stage slot in another tab. Click on Browse for both the slots to see what is there inside each slot. Both has default page. Now download the publish profiles and deploy our code into two slots. Click on Get Publish Profile of Production Slot. Click on Get Publish Profile of Stage Slot. Navigate back to Visual Studio and deploy the code. Right-click on Project, click on Publish. Click on New, click on Import Profile. Select the production slot Publish Profile, click on Publish. Code is being published to production slot. Next we'll do the same for stage slot. To make it fast, I have deployed the code to stage slot with the same process. I am skipping that in this video. Now open the browser and reload the production and stage slots. You can observe that the code is deployed to both the applications. Now go to Azure and update the app settings for both the applications. First configure them for stage slot. Go to Configuration section and click on Add New App Setting. Copy the keys from Visual Studio. Give the values as stage. Here I am just giving the slot name as value. For slot setting key, check Deployment Slot Setting checkbox. Click on OK. Add another app settings by clicking on Add New App Setting. For non-slot setting, also give the same value. For non-slot setting key, do not check the Deployment Slot Setting checkbox. Click on OK. Click on Save. Click on Continue. In the same way, configure the app settings for production slot. For both the keys, give the value as production. Check the Deployment Slot Setting checkbox for slot setting key, and do not check it for non-slot setting key. To make it fast, I have already configured app settings for production slot. Now switch back to web applications and refresh them to see the updated app settings. Now most important and the crazy stuff starts. Swap operation is important part in deployment slots. Go to Deployment Slots and click on Swap. Here we are swapping production and stage slots. We will see Perform Swap with Preview option in our upcoming sessions. We will discuss Config Changes section in a bit. Before clicking on Swap Complete operation, let us try to understand what happens behind the scenes when we do swap. As shown here, each slot URL points a virtual IP address. Assume that production slot is pointing to 192.168.10.10 and stage is pointing to 192.168.10.11, and each slot contains its own app settings configurations. So when we do swap operation, non-slot settings would be swapped and then virtual IP address of the slots will be swapped. So no deployments will be happened in this process. That is the reason it is called as zero-time deployment. And slot settings are also called as sticky slot settings, those won't be swapped. With this in mind, flip back to Azure and complete the swap operation. Click on Close, refresh the web applications, and observe the results. If you observe, the non-slot settings were swapped, go to Stage Slot and refresh to observe the same. Now let us see how to test production code with real-time users. Switch back to Visual Studio and do some code changes to the existing application. Deploy the code only to Stage Slot. Refresh the Stage Slot and observe the changes. Stage Slot contains new code changes, whereas production code contains old code. Now configure the traffic for Stage Slot to route the half of the request to Stage Slot. With this settings, when we access the production slot URL, some of the requests will go to production slot, and some of the requests will go to Stage Slot. Open the new instance of the browser and navigate to production slot URL. If you observe, we got the response from Stage Slot. In this way we can test our code with real-time users. In real time we can configure traffic like 90 and 10, so that we can verify our code with 10% of the users. Now let us try to understand how the request is navigating to production slot or Stage Slot. Open Developer Tools in browser by pressing F12, go to Application section, and go to Cookies, and look for TIFF mix key. Here if the TIFF mix value is more than 50, then request will go to production slot. If it is less or equal to 50, then the request will go to Stage Slot. Clear this cookies and refresh the application, repeat the same and observe the changes. Now the TIFF mix value is more than 50, so we got the response from production slot, who will calculate this TIFF mix value and other advanced information we will discuss in our upcoming sessions. Once after testing code with real-time users, we can change the traffic percentages back to original. We can swap the slots to move our changes to production. Our new changes moved to production and old code moved to Stage Slot. Here you can observe non-slot settings also came to original position as we swapped twice. That's all from this video. Thanks for watching the video. Please do like, share, and subscribe for more latest updates. If you feel something is not clear, add in comments, we will respond.